If there were life on Jupiter. The natural environment of Jupiter differs significantly from that of Earth in various aspects. The most notable difference lies in the composition of the atmosphere, which consists primarily of hydrogen, about 90%, and helium, around 10%, along with various gases such as methane, ammonia, and water vapor. This results in a very thick, dense atmosphere. In contrast, Earth's atmosphere is mainly composed of nitrogen, about 78%, and oxygen, about 21%, which provides the essential oxygen necessary for life. Furthermore, the temperatures and climate conditions vary greatly. Jupiter's atmospheric temperature is extremely low, plummeting sharply with altitude, where temperatures in the upper atmosphere can reach -145 degrees Celsius. In comparison, the average temperature on Earth is about 15 degrees Celsius, maintaining a suitable temperature range for life. In terms of gravity, Jupiter's is about 2.5 times stronger than Earth's due to its massive size and volume. Structurally, Jupiter is a gas giant with no solid surface, consisting of layers of liquid hydrogen and helium, and it is believed that more profound layers may comprise materials like metallic hydrogen under high pressure. In contrast, Earth is a terrestrial planet with a solid surface and a diverse array of topographies, including mountains, valleys, and oceans. Additionally, Jupiter has an incredibly powerful magnetic field, more than 20 times stronger than Earth's, that protects its moons from cosmic radiation. Lastly, Jupiter's atmosphere features massive storms, like the Great Red Spot, which can persist for hundreds of years and exhibit immense size and intensity, while Earth's weather systems are relatively smaller and more diverse, changing with the seasons. These differences highlight Jupiter's environment as extreme compared to Earth, which provides conditions conducive to life. Life on Jupiter would evolve in response to its unique environmental, physical, and chemical characteristics. The extreme atmospheric pressure, low temperatures, and gaseous makeup would compel any potential life forms to adapt in fundamentally different ways compared to terrestrial organisms. Such life forms might develop lightweight, flexible body structures allowing them to float within the dense atmosphere. They are likely to evolve buoyant gas sacs to maintain their position in the clouds and possess advanced chemical sensing abilities to navigate their environment and communicate. Additionally, these beings might develop special proteins to retain heat, enabling them to survive the extreme cold, and could potentially harness ultraviolet or other forms of radiation for energy generation, similar to a form of photosynthesis adapted to their unique surroundings. Cognitively, life forms on Jupiter would interact with their environment in ways dissimilar to Earth's organisms. They might rely heavily on chemical cues rather than complex visual signals, using accumulated experience to perceive and interpret their ecosystem. Interactions among these life forms would likely focus on cooperative survival strategies, allowing them to share resources and develop social structures that emphasize collaboration. The encounter between humanity and Jupiter's life forms could unfold through various imaginative scenarios. In one potential scenario, a human exploration spacecraft might accidentally discover these life forms within Jupiter's atmosphere. The sensors on board could detect chemical signals, interpreted as attempts at communication from the life forms. Researchers would analyze the signal patterns and attempt initial contact, leading to observations from the life forms that humans are not a threat. This scenario would prompt humanity to announce the existence of these life forms to the wider scientific community and initiate careful research. Another scenario could involve intelligent communication between both entities. If Jupiter's life forms actively sought to interact with humanity's spacecraft, they might convey their intentions through distinct chemical signal patterns. Upon deciphering these signals, humans would strive to foster mutual understanding. During this process, they could exchange insights about their respective ecosystems and cultures, leading to a more profound relationship between the two life forms. A final scenario might encompass conflict and cooperation. After initial contact, human exploration could inadvertently infringe upon the habitats of these life forms, triggering a sense of threat. The life forms might adopt defensive behavior against human encroachments, culminating in potential conflict. This escalation would ultimately transition into negotiations focusing on understanding and protecting their respective existences. Through collaborative discussions, humanity would seek peaceful coexistence with Jupiter's life forms, leading to the development of resource sharing and cooperative models based on different biological and environmental perspectives. In conclusion, life on Jupiter would evolve under unique environmental pressures, and contact with humanity could open pathways to unexpected exchanges and insights. Such encounters would provide humanity the opportunity to redefine life's meaning in the cosmos through interactions with new forms of existence. Meeting life forms born in the atmosphere of a distant planet would not only extend the scope of scientific exploration but also pose profound questions about humanity's place in the universe.